Okay, we're now going to look at how to solve systems of equations in which they're inequalities. So that means that we have less thans and greater thans as part of the equations. And in general, this means that not only will, for instance, for two lines, the solution include the intersection of the two lines, but it'll also include all the points in an area between the two lines that solves both equations. And so, for example, in this particular case, this area is greater than both of these lines, and so there'll be solutions that solve both of them. We looked at some of this before in section 3.7 when graphing a linear inequality. First graph each equation as if it had an equal sign. If the line has a greater than or less than symbol, graph the line as a dashed line. Notice these do not have lines underneath, whereas these ones do. Then you would use a solid line. And then when we want to decide where to shade, we're going to use a test point. Very often 0, 0 is a good test point because it's very easy to evaluate the equation with x equals 0 and y equals 0, unless the equation, the line goes right through 0, 0. And then basically if the test point is a solution, that's the side we shade. If the test point is not a solution, then we shade the other side of the equation. Now, this will include straight lines, but it'll also include other types of equations as well. So let us first look at problem 1 here. We want to graph the following. We've got y is less than or equal to negative 2x plus 4. So that's a straight line. And then y is greater than 3x. Now this one, notice there's no plus b part in y equals mx plus b kind of form. So this one's going to actually go through the origin. And so 0, 0 would not be a good case for that one. So let's start off with the first one here. This goes through 4, so it's going to go through right here. It's got a slope of negative 2, so down 2 over 1, down 2 over 1, and so forth. So our line will go through those points. We do have a line underneath the less than symbol, so it will be a solid line. So we can go ahead and do that. And so this is the first line. Now, the second one, as I said, so there's no plus b part. It'll go through the origin. Its slope is 3. So up 3 and over 1, up 3 and over 1. You can also go down 3 and back 1, down 3 and back 1, so that you have plenty of points. This one, however, will be dashed because there is no line underneath. So there is the second line. And now basically we have 4 spots that could be shaded based on those 2 lines. And so we're going to pick a test point and see how that works. Now, since the one line does go through 0, 0, I'm going to use as my test point, I'm going to use 0, 1. So the test point will be right here. And again, if that makes the equation come out true, then we shade that point. If it does not come out true, then we shade the other side of the equation. So let's see. Let's look at the first one. So we would have 1 is that less than or equal to negative 2 times 0 plus 4. Of course, negative 2 times 0 will be 0. Is 1 less than 4? It is. So we would shade the 0, 1 point. And now let's check the other one. Is 1 greater than 3 times 0? That is also true. 1 is greater than 0, so that one will work. So again, we would shade the 0.01. And so in both cases, we're going to shade the side of the line that will include the 0.01. And so in this case, we're going to shade like this. So in both cases, we are ending up to the left of the lines. We're not going to shade down here because that would be on the other side of this line. We're not going to shade up there because that would be on the other side of this line. We have to stay to the left. So basically shade left for both of these. And so we have to pick the area that works for all of them. And so that's an example of the solution area for those two lines. Okay, let's look at a second example here. We've got y is less than or equal to 3x plus 3, and I've got y is greater than or equal to 3x minus 1. In this case, we have two straight lines again. They do not go through the origin. So let's start off with the first one. Oh, and they're both solid lines because we have the lines underneath. So the first one is going to go through 3. And again, it has a slope of 3x. So 1, 2, 3, 1. Now I'm running out of room here, so I'm going to go back. 1, 2, 3, and then back 1. 1, 2, 3, and then back 1. So that will be the first line that we have. The second one goes through -1, and it also has a slope of 3. So 1, 2, 3, 1, 1, 2, 3, 1, and up there, 1, 2, 3, back 1. And in fact, since these lines have the same slope, they both have a 3 in front of the x, they are parallel. So there are my two lines. And in this case, I can use the point 0, 0 since neither line goes through that. So we're going to test 0, 0. And again, if the test point works, we shade the test point side of the line. If it doesn't work, then we shade the other side. So in the first one, we would have is 0 less than or equal to 3 times 0 plus 3. Well, 0 will be less than 3, so we will shade the side that has 0, 0 for that first line, and that's this one here. And since the 0, 0 is on this side, we're going to shade right. And then in the second equation, we have is 0 greater than or equal to 3 times 0 subtract 1. Well, 0 is greater than -1, and so we are still going to shade the 0, 0 point, but in this case, we are to the right, or excuse me, to the left of the second line. So the right of the first line, but the left of the second line means we're going to shade in here. And so there's our solution for that case. All right, now we have one that includes a parabola. Notice it's x squared, so 2y is greater than or equal to x, or just greater than x squared. There's no line underneath, so it'll be dashed. This one is another one that's a straight line. It will have no line underneath. Let's go ahead and rearrange these a little bit so they're in a little bit more proper form that we're used to. So in the first one, we have x greater than 6 subtract 2y. So then we'll have 6 minus 2y less than x. Note I just switched both sides, and so the less than side still faces the 6 minus 2y part. Okay, move the 6, and we have negative 2y is less than x subtract 6. And then divide everybody by the 2, negative 2, which means I have to switch this to greater than, and then we'll have negative 1/2 x plus 3. So this will go through 3 on the y-axis, but its slope is negative 1/2. For the other one, we have x squared is less than 2y. So again, I'm just going to switch it around. So 2y has to be greater than x squared. Again, the big side of the symbol still faces the 2y. Divide both sides by the 2, and so I have 1/2 x squared. Basically what this 1/2 will do is make the parabola a little bit wider than it would have been before. In other words, I have to have 2 and 4, and so forth. If there was no half here, 1, 1, and then 2, 4, and 3, 9, and so forth. But since I have the half there, it's going to be half of those kinds of things. So let's go ahead and graph our two lines. First off, the one that goes through 3 and has a slope of negative 1/2. So 1, 2, 1, 2, 1, 2. And again, we can go back. And so it's going to go through there, but it is going to be dashed. So there's the one line. Okay, for our parabola, if I have 0, of course y is 0, so it's going to go through here. Let's go ahead and do the even numbers, because 1/2 of the even numbers will still be whole numbers. So if I put in 2, 2 squared 4, half of 4 is 2, so 2, 2 is a point, and negative 2, 2 is a point. Let's go to 4. So 4 squared is 16. Half of 16 would be 8. So 4 is going to be 8. So that would be right here. And negative 4 would be right there. Since we're already off the graph, let's go ahead and do 3 anyway, just to kind of help our graph here. Half of 9 would be 4.5, so 3 is going to give me about right through there, and negative 3 again about right through there. So that one is going to go pretty much like this. And of course, they could keep going as far as you wanted to go. So there are our two lines, one a parabola, the other a straight line. Now we still want a test case. Since this one again has gone through 0, 0, let us do a test point of 0, 1. That would be right here. So first off, so that's x is 0, y is 1. So in the first equation we would have is 0 greater than 6 subtract 2 times 1. Well, that's 6 subtract 2, that's 4. 0 is not greater than 4, so that's no. So don't shade 0, 1, shade other side. So we were looking at the straight line part, so we're not going to shade the side down here that for this line. Instead, we're going to have to go above the straight line. Okay, what about the parabola part? Because above that could be in here, but it also could be out here, so we have to check which one of those is going to work. So using the second equation is 0 squared less than 2 times 1. That is true, 0 is less than 2. So in that case we do want to shade the side that has 0, 1 on it. So we're talking about the parabola. So here's the 0, 1, so that means we have to be within, so we have to be shade within the parabola. So we need to be above the 1 line, but within the parabola, and so we would end up shading this. This would be what we would shade. And there's our solution for part C. Alright, so now in this last case we've got some absolute values. Remember that absolute values tend to look like V's instead of U's that the parabolas are. And so let's see, first off we have absolute value of x is less than or greater than 3. Now actually, since this is not a y equals absolute value of x, this is not actually going to be in a V-shaped. Instead, all we've got is just the x. So that means anytime you have just one letter, it's a straight line. Since we have an inequality, then it's going to be between two straight lines. And since this involves x, the two straight lines are going to be vertical. So one of the lines will be here. And one of them will be over here. And, you know, since this is a less than, we have to have numbers that are going to be in the inside of that. In other words, for instance, 0. So that's where the first one is. The second one, we have y is less than or equal to 0. And so in that case, that's on the x-axis, is that line. So that one's going to be right through here. And that's where the second equation is. And this is the only one that's diagonal because it's got both x and y. It goes through 1. It does have absolute value, so that this will have the V shape. This one will start off here, and since it has a slope of 1, it's going to go this way, up 1 and over 1 and so forth, and it's also going to go this way. So that's what that one's going to look like, and they all are solid lines because they all have a line underneath them. So the last one is going to go in that direction. So there are all our lines. Okay, now let's see, we've got one line on the 0, 0, so we don't want to use that as a test point. This one's on 0, 1, so we don't want to use that as a test point. So let's use as a test point 0, negative 1. So that'll be down here as our test point. So in the first equation, is the absolute value of 0 less than or equal to 3? Well, yep. So that means, again, shade between lines. So we're going to shade in here. Now let's try the next one. Is, let's see, that one we've got the y is -1, is -1 less than or equal to 0. That's true. So now it says I have to shade below the y equals 0 line. And if I look at the last one, that one says, let's see, is -1 greater than or equal to 0 plus 1? Well, that's going to give me 1. -1 is, so that's a no. So that one says don't shade the 0, -1. So don't shade down here. In fact, this one would say, you know, we need to shade within V, if you will, which, you know, if we were shading it, would be up here. Whereas the other two say we're going to be shading in here because it's got to be between the two lines and it's got to be below this line. So the one is shade up there, the others are shade in here. There is no common area, and therefore no solution. There is no point that will satisfy all three equations. And so some examples of solving systems of equations with inequalities.